Okay, hello. So this is a short presentation on the history of forensic science, and basically it goes through some of the key events that have occurred over that history. It's absolutely fine to use these, you can find others, but I just thought I'd record it because it's easier because you can rewatch it. Okay, so in terms of the learning objectives, they are to identify some key milestones, or millstones as it says here, in forensic evidence, and to describe key historical milestones in the development of forensic science. So essentially it'll be a timeline, and I want you to tell me some of the key historical dates in forensic science and describe some of them, 10 or thereabouts. Try and bring it relatively close to the present day, that'd be great as well. So basically, Archimedes was one of the first people to ever use forensic science. He basically found that, if you jump into a pool, for example, an equal volume to your body of water will leave the pool. So he basically found a method of determining weight or volume. So he later used this when the king of Syracuse had been deceived to prove that the thing that he was given wasn't gold, it was mixed with silver, which is obviously awful. But, the point being that even thousands of years ago, they were using scientific methods to try and solve problems and trying to uncover when bad things had happened, in this case, the king being deceived with silver rather than gold. So fast forward a bit in time, Solomon, an Arabic merchant, he used fingerprints as a proof of validity between debtors and lenders. So you would put your fingerprint on a bill, and that would prove that it was you and that you would honour it and things like that. And we know about fingerprints nowadays, and it's something that we think about all the time when we watch CSI. Have they taken fingerprints? And it's become part of popular consciousness. The Chinese also used the fingerprint. So the first document that ever mentioned it was Zi Huan Zi Lu, Collected Cases of Injustice Rectified, written in 1248 by a Chinese author, Song Si. Autopsies, which is something that happens after someone's died to find out why. Obviously, I imagine you know that. But they were first performed from 1302, which is a very specific date in Bologna in Italy. We know that happens now. It's standard procedure, particularly if something suspicious has happened. And obviously then they wouldn't have had the methods, the scientific methods that we have now, but it's something that developed really early. So there you go. Gruesome work of art. I don't know the artist. Wouldn't imagine you'd want to hang it on your wall anyway. Sudaviranyana examined the bodies of people who had died in suspicious circumstances to determine the cause of death. Obviously, his observations were limited by the power of human eye and his tools. Even fingerprints back in the day when they were first invented, it was the human eye that they would use, and they would use their intuition and their judgment to determine whether the fingerprint was a match. Nowadays, we have much more sophisticated methods. Are those methods better? If so, why? If not, why not? Quite widespread from the 16th century. Medics began to use their knowledge to investigate the cause of death. This is, the start of the Enlightenment era, and the idea that we could find out why people had died using scientific methods. Obviously, it was in its infancy. Ambrose Paré, Fortunato Fidelis, and Paolo Zacchia, some of the pioneers in this field. You don't need to know these names, obviously. The invention of the microscope in 1590 enabled the discovery of things like red blood cells. Obviously enabled us to see things at closer magnification, so we could, see some of the nitty-gritty about what was going on, and see some things that can't be seen with the human eye. Dust particles and blood that's been left behind and things like that. So here it says, human remains were identified using teeth for the first time, something that we take for granted. Dental records are used, but obviously until they had microscopes, they weren't able to do that in the same way. And that's a human hair. However, no matter how powerful the microscope, some causes of death remained undetectable. Why do you think this was the case? I'll leave that up to you to answer, but it could be because they didn't have the scientific knowledge. It could be the microscopes weren't as powerful as they are today. Detecting poisons. So arsenic, you've probably heard of arsenic. It's a poison that used to be used as a murder weapon. 1832, it was first used as evidence, and they could find arsenic in someone's system for the first time. Before then, it was basically undetectable. They called it inheritance powder, apparently. And it's something that, if you read the whole books, you hear people being poisoned with arsenic. It's not something that happens really nowadays. So James Marsh designed a test for arsenic, and this allowed us to develop the science of toxicology. Nowadays, one of the things that we do when someone dies is we find out what's in the system, what chemicals are in the system. Have they been poisoned? Have they taken a drug overdose? Have they drunk too much? Whatever. We can do that now. Before 1832, we couldn't do that for arsenic, and before, various other dates, we couldn't do it for other things. Another thing that developed was bullet matching in 1835. The first time Scotland Yard traced the bullet back to the original mould, discovered the person who bought it. Obviously, they probably have much more sophisticated methods to do that now. Not used in the first time until 1926. Obviously, one of the things that we look at nowadays is gun crime and weapons at the murder scene, because guns are increasingly used in crime. Bullet matching helped the police to trace gun owners, obviously. There's a bullet. Photography then developed, and obviously it's very important for documenting the crime scene, for documenting the criminal, and as well as photography, obviously film in the form of CCTV and things like that. So photography first began in the 1830s. Very time consuming at first. You had to stand still for hours. Well, not hours, but you had to stand still for a large period of time for the photo to be taken. So following photograph taken in 1838, what are the problems with that photograph? Quite blurry, quite difficult to identify the people. It's in black and white, so you can't see what color clothes they're wearing, etc. Much more sophisticated. Cameras are much better, obviously. So photography obviously improved, became a way of recording things. And obviously you could record the crime, you could record the criminal, and 1870s onwards, imagery was better. So we could document a scene. Obviously, sorry for the sensitive imagery. Also mugshots. So it led to people being more interested in crime and criminals, and they put these photographs in the newspapers, and it raised the profile of forensic science. It also helped the police because people would give them information. So Swedish mugshots, or Swedish newspaper with mugshots in it. Guy called Alphonse Bertillon developed a scale by which you could light and identify faces in profile photographs, and that's what kind of started to happen from this period. They started to come up with these classification systems that they would use for classifying things, for example, a face or a fingerprint or whatever else it is. Fingerprints. So in 1892, the very first fingerprint bureau was established in Argentina. We've probably all seen this, hopefully not firsthand, but you've seen fingerprints, and you've seen them as part of TV shows and things like that. The very first case was apparently in 1910. A guy called Thomas Jennings. He grabbed onto a railing and it left behind the fingerprint. Francis Galton, who was a pioneer in fingerprinting, he calculated the chances of identical prints were 1 in 64 billion. As you will probably know, there's not that many people in the world, so chances are you have unique fingerprints. They also come up with systems to classify fingerprints, and for example, they were increasingly used to identify retiring soldiers so their relatives couldn't keep claiming their pension after their death, which would be awful. And it's still something that we use today. We use more sophisticated systems and technology and things like that, but it's still something that happens as part of a criminal investigation. Another thing is blood types. We have ABO system. There are some other systems, first discovered in 1900. We'll be doing that as part of the unit, but you may know your blood group, you may not. Some people are universal donors, some people are universal recipients. And that's useful in forensic investigation, but it doesn't narrow it down to an individual. If you're interested in literature and TV, Arthur Conan Doyle, who wrote Sherlock Holmes, he actually wrote about blood analysis way before it was possible in reality. But yeah, these tests were crude originally, gave inconclusive results in anything but the simplest cases. And to a certain extent, blood typing is inconclusive because, like I said, it doesn't narrow it down to the individual. You require blood from the crime scene, so obviously it's not ideal because not all crime scenes have blood. It might have to be a murder or a violent crime or something like that. So Edmund Locard, he was a pioneer in forensic science. Every contact leaves a trace. So basically, if you look at a crime scene, there's always going to be something that you can find from that crime scene that's going to implicate somebody. If you've touched something, walked on something, you are going to leave a trace behind. And he had started setting up crime labs. Controlled environment led to an important discovery. He looked at particles of dust and developed one of the fundamental principles of forensic science. Like I said, everybody will leave a trace behind and will take something with them. If you merely brush against the wall, you're going to take some microscopic piece of the paint or something like that, and that's going to be able to trace you back, particularly now with the sophisticated methods that we have. He called that the principle of exchange. And the next revolution in forensic science was the discovery of DNA. We take that for granted nowadays, but it's a relatively recent discovery. I was reading a book this morning, The Postman Always Rings Twice, and I was thinking, how did they solve crimes before they had DNA? It's amazing that they managed to do it. DNA allows us to identify anyone's unique biological code. So basically, we could identify an individual for the first time inconclusively from a sample. It replaced blood as the most powerful method of identification. It's invisible to the naked eye, but you can detect it in traces left behind by all but the most careful criminals. One aspect of this unit is what kind of DNA evidence will be there. Think urine, semen, blood, etc. Originally, the results took ages, weeks, but then within 15 years, they narrowed it down to a couple of days. And in the UK, we have a DNA database, which you could, put your sample into and then find out whose the sample is. In itself, it's quite controversial. Should the police be able to keep our DNA on file and things like that? The very first DNA conviction for murder was in 1988. It was a guy called Colin Pitchfork. Quite an interesting case. I won't say too much about it because you can use this as part of your assignment. But yeah. And then obviously computer evidence has revolutionized the way we tackle crime. So rather than using our judgment or human judgment or the human eye, we use computers, and that can filter out the records and then allow us to find the individual that way. We also use things like computer graphics to create a model of a person or a model of a crime scene, bullet trajectories, things like that. They can be criticized as potentially misleading due to their persuasiveness. You know, if you look at an animated reconstruction of a criminal, you're going to think it's the person that looks most like them, I guess. So that's one of the negatives of technology, because it can be so persuasive that people are fooled by it, whereas in the past it would be more about human judgment, if you like. We still have magnetic fingerprinting, alternative light photography. You know, when people go into hotels and they shine the blue light and they can see all the things on the bed sheets and things like that, that's alternative light photography. And forensic science will continue to develop. You know, think about the future, what's going to happen in forensic science, and you know, the availability of the science to be able to tackle and apprehend criminals is amazing nowadays. So imagine what it would be like in 50 years, 100 years time. Thanks very much for watching. Bye. Just leave you with that question.